Today you will apply the properties of similar triangles to real-life problems. You can use indirect measurement to find the lengths that are difficult to measure directly. One of the strategies that is used quite a bit when solving real-life problems is drawing a diagram. In geometry, that is the best thing that you can do. So you're going to draw a diagram, label the diagram according to the corresponding parts, answer the question using the properties of similar triangles. So in other words, you're going to set up a proportion to solve for that unknown. And then if you have to round to the nearest hundredth. The first problem is known as a shadow problem. At a certain time of the day, shadows are being made, and therefore proportional figures and similar figures are also being formed. Here you have two trees that cast a shadow. The smaller tree is casting a shadow of 5 meters, and at the same time the evergreen is casting a shadow that's 8 meters long. The height of the smaller tree is 14 meters, and we want to determine the height of the evergreen. So the picture is already drawn for us, so all we need to do is label what we're looking for, which is the height of the evergreen. So we're going to let this be H. Once you've labeled your diagram, now it's time to set up a proportion. So if these two shadows are being formed at the same time of the day, then the ratios are the same. So therefore, we can set up a proportion of the height of the smaller tree, which is 14, is to the height of the evergreen, which is H, and set it equal to the shadow that the smaller tree is casting, which is 5, is to the shadow of the evergreen. Now notice my numerators, those numbers are coming from the first picture, and my denominators are coming from the second picture. So you have to have some order into how you set up these proportions. So now we can use either the bat and ball method, or we can use cross multiplication. So 5 times H, which is 5H, is equal to 14 times 8. And 14 times 8 is 112. We want to undo multiplying H by 5, which would be to divide both sides by 5. And 112 divided by 5 is 22.4. So the height of this tree is 22.4 meters tall. Now we want to look at a problem where you are looking for the distance across the river. Distance is a perpendicular segment. So therefore we're looking for this distance right here across the river. So now we need to figure out, well, what's going on with these two triangles? Well, the two triangles are similar to each other. So if I were to take the smaller triangle and rotate it clockwise 180 degrees, you'll notice that the right angles are congruent to each other, and these two angles are also congruent because they're vertical angles. So we can set up a proportion to find D, which is the distance across the river. So the distance across the river is represented by D, is to the other altitude, which is a perpendicular segment, 7, is equal to the distance from the right angle to the smaller vertical angle, which is 32, over the distance from the vertical angle to the other altitude, which is 12. And you have two methods to use, bat and ball or cross product. So I'm going to use bat and ball. So the bat is 32 and 7. So I'm going to multiply those two numbers together. And I end up with 224. I'm going to divide it by the ball, which is 12. And I end up with 18. And there are a lot of sixes repeating after the decimal point. So I get about 18.6, and the 6 repeats. So what I want to do is round. So this will be approximately 18.67, round to the nearest 100 meters. So the distance across the river is approximately 18.67 meters. Now we have another problem where you have triangle inside of a triangle. Now this one's done a little bit different than the rest of them. So here you have a man who is 1.8 meters tall. And then the CN Tower is 457 meters tall. The distance the man is from this acute angle is 100 meters. But the distance from this angle to the CN Tower is 100 plus another distance. And so we're going to let this distance right here be x. So the distance from the acute angle to the right angle is x plus 100. So now we need to go ahead and set up a proportion and solve for the unknown. Now remember, we're looking for the distance that man is standing away from the tower, which is x. So we're looking for x. So let's set a proportion up. The height of the man, which is 1.8 meters, is to the height of the CN Tower, which is 457, is equal to the distance the man is from that acute angle, which is 100 meters, over the distance from the acute angle to the right angle, which is x plus 100. Now this problem has to be worked a different way, but you're still going to use cross products. So I'm going to multiply 457 times 100, which is 45,700, and set it equal to 1.8 times the quantity of x plus 100. Now, in order to solve for x, what we must do now is use what is known as the distributive property. So you're going to multiply 1.8 times x, which is 1.8x, and you have to multiply 1.8 times 100, so you move the decimal point twice to the right, so that'll be plus 180. And set it equal to 45,700. Now we just have to complete it by using algebra. So I'm going to subtract 180 from both sides. What you do to one side, you must do to the other. All right, so let's simplify this. Cross out 0, so 1.8 x is equal to 45,520. Because you want to subtract 180 from 45,700. And now I want to divide both sides by 1.8. So x is approximately 25,000 288.9 meters. So the man is standing from the CN Tower approximately 25,288.9 meters. Now the last problem is dealing with shadows also, but this time the pictures are not complete. So here you have a lamppost that is 2.5 meters high. So the height of this lamppost is 2.5 meters. Label it. It's casting a shadow that measures 1.8 meters. So it's a shadow and it's 1.8 meters. And nearby you have a flagpole that is casting a shadow also of 3.2 meters long. And if these two things are happening at the same time, then similar triangles are being formed. So I am going to connect them together the best I can. Calculate the height of the flagpole. So we're looking for the height of the flagpole. So we can set up a proportion. The height of the flagpole is to the height of the lamppost, and is equal to 3.2, which is the shadow of the light pole. The flagpole is to the shadow of the lamppost. If these two things are set equal, cross products are the same. So we're going to multiply 3.2 times 2.5, and that gives us 8. And we're going to set it equal to 1.8 times h. Divide both sides by 1.8. What you do to one side, you must do to the other. And so h is equal to 4.44 liters. And in this case, we had to round. So the height of that flagpole is approximately 4.44 meters tall. Now that's it for similar figures. And I hope you've learned how to set up proportions for the word problems. Please make sure you go to your assignment and do those problems, and make sure that you turn them in by the deadline. Thank you.